Today we are going to be graphing two variable inequalities. So again, we're continuing with chapter 9, inequalities. We've done graphing inequalities on a number line, solving inequalities, one variable inequalities, again on a number line, absolute value equations, absolute value inequalities, which we graph on a number line. And today we're going to be graphing two variable inequalities. I put linear here because we're actually going to be graphing lines on an XY axis. So graphing two variable inequalities. Okay, so again, graphing two variable inequalities. So we are going to think about the inequality as an equation. And graph the line. And this line is going to be, unlike our boundary points we had with our inequalities and our absolute value inequalities, this is going to be a boundary line. And instead of having an open circle as a boundary point or a closed circle as a boundary point, we're going to have a dashed line or a solid line. So the dashed line is if we have less than or greater than. That's going to be a dashed line if we do not have the equal. It's going to be a solid line if you have less than or equal to or greater than or equal to. Okay. Then after you draw your dashed line or your solid line, you have to decide where to shade. Okay. So then decide where to shade. Now you can always test a point to see where to shade, and I'll show you how to do it that way. But the way I do it is the following. Okay. So if it's in Y form, okay, need it in Y form, Y is greater than mx plus b, then what's going to happen is, since it does not have the equal, okay, it is going to be a dashed line. And these are lines. So pretend that my pen is a line on a graph. And I need to decide where y's are greater, where y's are bigger than this line. So if this is a line and I go above it, these are y's bigger than my line because y's are up and down. And if I go below, these are y's that are less than. So if I want y's that are greater than, I am going to shade above line. Now, if it's y is greater than or equal to, what that's going to do is it's going to then be a solid line, again, because of the equal. And then since it's greater, again, greater y's are above, smaller y's are below. So we're going to shade above. Okay, so these are my ones that are above, greater or greater than or equal to. So I'm going to do similar with my less than and less than or equal to. So y less than mx plus b, again, without the equal, is going to be a dashed line. And this time, since it's less than, I'm going to shade below. Move it up a little bit. And if it's y is less than or equal to mx plus b, this is going to be a solid line, again, because of the equal. And we're going to shade below. Okay, again, because we want y smaller, we want y's under. So this is how I think about these. Now, again, the main idea here is that it needs to be in y equal form, well, y form, y on this side, everything else on the other side, for you to decide whether you're going to shade above or below. Okay, I'm going to go through examples that are in this form, and then I'll go through an example that's not. Okay, so let's jump into an example. So first example, let's say we have y is greater than or equal to negative 1/3 x minus 1. So looking at this little line here tells me it's going to be solid. And because it's greater, that means I'm going to shade above. Okay. Now, just a little reminder, we are graphing lines. So remember that y equal mx plus b. Your b is your y-intercept, and your m, the one with the x, is your slope. Okay, because we have to actually graph this. So let me draw my graph here. Okay, so I need to get down to a -1. Okay, and just a little reminder, this is your x-axis, and that is your y-axis. And again, looking at this, let me just identify my y-intercept is -1, this number here. So that means I'm going to come to my y-axis and I'm going to come down to -1 and put my point. My slope is the number with the x, so that's a -1/3. Now, when I do slopes, if my number's positive, I go up. If my number's negative, I go down. So I always think about this positive or negative on top. So my top is negative, so I'm going to go down 1. And then whatever's on the bottom, think right, okay? So have your sign be associated with the top. Positive, go up. Negative, go down. Whatever number's on the bottom, you're going to go right. So we're going to go right 3. Okay? So from here, I'm going to go down 1 and right 1, 2, 3. And then I'm going to put my point. And if you want to do more points, you can do more points. Okay, I can continue doing it going backwards if I want. Now I'm going to connect these. Okay, let me just do maybe one more. So if I go down 1, right 3, going backwards, I go up 1, left 3 if I'm going backwards. And I'm going to draw my dashed line. Let me get my ruler. Actually, this is going to be a solid line. Okay, solid line. And what that means is everything on this line that I just drew in purple actually is going to make this true. It's going to make it equal. Now I need everything that's going to make it greater. So again, you want to think above is greater, below is less than. So if I come here, sometimes it helps to come to your y-intercept and you go up, then this is going to be above. And if I went to my y-intercept and I went down, this would be below. And again, I want to shade above. So I'm going to shade everything here. And you have to shade. Shading is your answer. Okay? Everything I'm drawing in yellow right now, shading in yellow, makes this inequality true. Okay? And this keeps going on forever and ever and ever, out and up. Okay? So anything in yellow, any point here is going to make this inequality true. It's going to make it greater. Anything on the purple line here is going to make it equal. So both the line and the shading make this inequality true. So both of those are my answers. You're not going to write out a number answer. This graph is your answer. Okay, so let's try another example. So let's say we have y is less than or equal to 4x plus 2. Again, it's got the equal, so that means it's going to be solid. And less than means you're going to shade below. Okay. Now, if I'm identifying my y-intercept is this 2. So let me just jot that down. Y-intercept is 2. And my slope is this 4. So my slope is 4. Now, when your slope is a number that's not a fraction, okay, so like a whole number or an integer, you can always put it over 1, and now it's a fraction. So whatever's on top, that's your up or down. Since it's positive, I'm going up 4. And then whatever's on the bottom, you're going to go right. So right 1. So before I start graphing this, I need to be able to get up to 4, sorry, up to 2. And then I need to go up 4 from that. So let me just space this properly. So I'm going to kind of have it, my x-axis down further. Okay, so my y-intercept is 2. So on my y, I come up to 2. And then my slope is 4, which means up 4, right 1. Up 1, 2, 3, 4, right 1. Okay, and that's my line. It's solid. So I'm going to draw a solid line. Let's get my ruler. So there's my solid line. So again, everything on this line is going to make it equal, which is part of my solution. Now I need to decide if I want to shade above or below. Now, sometimes as your line gets a little steeper, it's hard to think about above or below. Sometimes people are thinking more right or left, but you still want to think above or below. So if you go to this point here, my y-intercept is kind of a point I usually go to, and I go up. I go up. When I go up, I'm on this side, so this is going to be above, which means when I'm here and I go down, I'm on this side, so this would be below. Now again, I want to shade below. So in this case, I'm going to shade everything here. So everything I'm shading here in yellow is a solution. It's going to make this less than, it's going to make that part true. Where everything in purple, my line is going to make it equal. So both the line and the yellow are my solution. Now, I said I would show you how to do it if you wanted to test a point instead. I'm just going to do it as an example here. So let's say I wanted to test a point instead of deciding above or below. So an easy point to always test is 0, 0. So if you wanted to test 0, 0, again, here's 0, 0. You never want to test a point. Here's 0, 0. You never want to test a point that's on your line. You want to test a point that's on one side or the other of that line. Okay, so I'm going to take 0, 0 and put it in here. So I'm going to get 0 less than or equal to 4 times 0 plus 2. And I decide if this is true or false. I get 0 less than or equal to 2. And is 0 less than or equal to 2? True. So this side here made it true. And so since it made it true, I shade on the side that that point's on. If this point had made it false, I would have shaded on the other side. So you can also do it that way if you prefer. Okay, so next example. So let's say as an example, I give us something like this, 2x minus y less than 5. Now, one like this is not in the y form, okay? So you want to be careful. So first thing I need to do is get in y form, okay? So when I say get it in y form, I'm going to use the properties of inequalities. So you do not want to decide if you're going to shade above or below, because as I solve this and I use my properties of inequality, I might end up having to switch my inequality direction. when I add and subtract to both sides, my inequality stays. If I multiply or divide by a positive, my inequality stays. But if I multiply or divide by a negative, your inequality switches directions. So let's see what happens here. I'm going to get my y by itself. So I'm going to minus 2x. I'm going to minus 2x. And when I do that, my x's cancel out. And you want to make sure that you're bringing down this whole thing, including the negative. So this is a negative y. Less than 5 minus 2x, or some of us might like to write it as a negative 2x plus 5. Those are the same. Now, I almost have it in y form, but I have this negative here. So I need to get rid of this negative. So how do I get rid of a negative? I'm going to divide by a negative 1. Now, when I divide by a negative, you need to switch your inequality direction. Okay, we saw this when we did our first set of notes on solving inequalities. So I'm just going to rewrite this, okay? And I'm actually not even going to write the inequality sign yet because I want to see what's going to happen, okay? So I divide this by a negative, I divide this by a negative, I divide this by a negative. And again, when you divide by a negative, you need to switch the direction of your inequality. So this was less than. Now, because I'm dividing by a negative, it's going to become greater than. So this is going to be y is greater than negative 5 plus 2x, or 2x minus 5, if you prefer. So this is not my answer, but this is what I'm going to be graphing. This is what I'm looking at. So here, this one started out looking like it's less than that I shade below, but it ended up being one that I'm going to shade above because it's greater. The trick really is to look at what's happening to the y. The x you're going to add or subtract. That's never going to change the direction of your inequality. What's going to change is if you divide or multiply by a negative. And in this case, since this is a negative in front of my y, I'm going to divide and it's going to switch. If this had been a positive in front of my y, it would have stayed. That's where I kind of pay attention when I'm doing these. Okay, so now this is what I'm going to graph. And so for this, you're going to graph a dashed line because there's no line underneath. And since this is greater than, I'm going to shade above. Again, do not decide if you're going to shade above or below until you get it into y form. Y on one side, everything else on the other side. Okay, so now we're going to graph this. Let me just kind of shrink this down so we can kind of see a little more. Okay, so I'm going to draw my graph. I need to get down to a negative 5. So maybe I'm going to put my x-axis up here. X, Y. So my y-intercept, again, just to make sure, you don't have to write this out every time. I just want to make sure everyone knows where I'm getting my numbers, is this number here. That's my negative 5. So I'm going to go down 1, 2, 3, 4, 5. Okay, and I have that point, negative 5. Okay, let's try to get it to focus a little better, sorry. Okay, so now from here, my slope is 2. Again, 2, you can put it over 1 if you want to think about it as a fraction. The top number is your up or down, it's positive. So I'm going to go up 2. The bottom number is your right, and that's going to be right 1. So I'm going to come here and I'm going to go up 1, 2, right 1, up 1, 2, right 1. Okay, I'm just going to do it a little bit more. And again, this is a dashed line. So we hadn't seen one like that yet. Let me just grab my ruler. So if I'm doing a dashed line, that means everything on this line does not make this true. So if you were to draw this as a solid line, you're actually adding on an infinite amount of wrong answers. because there's an infinite amount of points on this, and every point on this line makes this false. So nothing on this line is a solution. So now I'm going to decide where to shade. We said we're going to shade above. Again, I come here. If I go up, this is above. And if I went down, this would be below. Okay, so we want to shade above. So I'm going to be shading everything here. And that's going to be our graph. Now remember, the graphs are your answer. So you want to make sure you are shading. Okay, you're not going to be giving me like a number answer or anything like that. Now, the last thing I want to talk about is sometimes we have lines that are vertical and horizontal. And I want to make sure we understand the difference between those. So a little quick note, if you have x equals some number, this is going to be a vertical line. Okay, it's going to go up and down. If you have y equals some number, this is going to be a horizontal line. And this is going to go left and right. Okay, so if you have x equal a number, you're going to have a vertical line up or down. If you have y equal a number, okay, not with an x or anything like that, just y equal a number, you're going to have a horizontal line. Now, these ones you would still be shading above or below. These ones have a y in it. These ones we can't shade above or below. So what's going to happen is we're going to shade either right or left. Okay. So if x is greater than a number, that's going to be dashed. And if you think about this pen being my vertical line, okay, as I go to the right, I'm getting bigger numbers. As I go to the left, I'm getting smaller numbers. So greater would be to the right, less than would be to the left. So it's going to be dashed and shade right. And x greater than or equal to a number, solid and shade right. Now, if I have x is less than a number, or x is less than or equal to a number, okay, x is less than, again, dash, because you don't have that sign underneath, you don't have the equal, the line underneath. Less than, I'm going to shade left. Now here, if it is x is less than or equal to a number, it's going to be solid. And I'm going to shade left also. So let me just jot that down here. Okay, so this you're going to be shading right because it's greater. These you're going to be shading left because it's less than. So I'm going to go through one example of a vertical and one example as a horizontal. So let's say I have x is greater than 2, and my other one, let's say we have y is less than or equal to 4. So this one is going to be dashed because it doesn't have the equal. And since it's one of these x ones, greater is going to be to the right. So I'm going to shade right. So I'm going to get my graph. Here's my x-axis, here's my y-axis. And I know it's a little confusing because you see that your x line here, your x-axis is horizontal, but on my x-axis, my y is constantly 0. This is 0, 0, 1, 0, 2, 0, 3, 0. Notice the y is constantly staying the same. What's changing as I'm moving is my x. I'm at my x being 0, 1, 2, 3, 4. So my vertical lines are actually going to be where my x is constantly a particular value. So for x is greater than 2, I'm going to go to 2 on my x, and everywhere here, my x is 2. Okay, everywhere here, my x is 2. So again, this is x equal 2. And I'm going to decide where to shade. Again, we want greater. So this would be 3 and 4 and 5. That's why we're shading to the right. And that's your graph. Okay, that's how you do vertical ones. Now, horizontal one, again, looking at this with the little line here, it's going to be solid. And it's less than or equal to, so I'm going to shade below, because these are like our normal ones that we were doing before. Okay, so I'm going to draw this. Make sure I can get up to 4. So again, on my y-axis, okay, this is my x is going to stay constant here, 0, 1, and 0, 2, and 0, 3, and 0, 4. So my x is constant here. My y is not. My y is changing. So I'm going to go up to 1, 2, 3, 4. This is where my y is 4. And my y is not 4 just there. 1, 2, 3, 4. My y is 4. And this is solid line all the way across. Everywhere here, my y is 4. 0, 4, -1, 4, -2, 4, 1, 4, and so forth. So this is where my y is 4. And then I want this to be less than. So it's going to be below, and that's going to be your graph. So you're going to be having some of these on your homework, these inequality graphs to variables, and then you have some review from our past 3 sets of notes. So that's the end of the notes, and good luck.